Good evening students, we will continue with the reactions of phenol, that is we are doing the electrophilic substitution reaction. So we have already done up to halogenation, nitration, sulfonation, we have done it. So today we will do the Friedel-Crafts reaction, we can see it on the screen. So we will take phenol plus CH3Cl in presence of anhydrous AlCl3. What I am going to get? I am going to get orthocresol and paracresol, where para is a major product, you know it. Why ortho is a minor product? Several times I have said you. Once again let me tell you that in case of ortho there is steric hindrance. Alright, steric hindrance means the two groups which are closer to each other, as you can see in case of the first one, orthocresol, the two groups OH and CH3, they will suffer steric hindrance. Electron clouds, when they come closer to each other, it will be unstable in nature. That is called steric hindrance or steric repulsion. But in case of paracresol, you can see the electron clouds are far away from one another. OH group and CH3 group, they are far away. That is paracresol, due to which para product is a major product. We can say that. Similarly, Friedel-Crafts acylation. The first one was alkylation. This is your acylation. Friedel-Crafts acylation means phenol plus acetyl chloride, CH3COCl. That is your acetyl chloride or ethanoyl chloride in presence of anhydrous AlCl3 will give you orthoacetyl phenol and para-acetyl phenol. You can see it on the screen. So para again is a major product. So you need to write these reactions and you have to understand it. Next is this one with neutral ferric chlorides. Is a test for phenol. I have already said you the test for phenol in with case of bromine water. You got a white PPT, isn't it? So this is also a test for phenol. We can say that. So what you have to do is that you have to add neutral ferric chloride solution. Now what do you mean by neutral ferric chloride? Actually you see ferric chloride is acidic in nature, because the way the ferric chloride is being prepared, that is ferric hydroxide with HCl and all those things, it is acidic in nature. So we neutralize the ferric chloride by adding ammonium hydroxide. Got it? That is alkali we added to it and we neutralize, that is ferric chloride. So that is called as neutral ferric chloride. Understood? That's very simple. You will do it in the lab also. Neutral ferric chloride you will be preparing in the lab when you will do the test for phenol. This particular test you will be doing it in the lab. When you will do it, you will see, you will prepare neutral ferric chloride yourself. At that time you will come to know this is the way you neutralize it. Fine. Now next is what you will see is that when you will add neutral ferric chloride solution, you can see the reactions there. It is a complex reaction. You can see a complex product is being formed there. Alright, with phenol, and the color will be either violet, red, blue or green depending upon the type of phenol. Type of phenol means, that is with phenol here you will be getting, that is nothing but green color. With this reaction you will be getting it. But suppose if you are taking orthocresol, if you are taking paracresol, if you are taking, that is benzyl alcohol, got it, in this way. So those also comes under aromatic alcohol. Phenol is nothing but an aromatic alcohol. So with those compound also, neutral ferric chloride will give a characteristics test. That is either the color will be violet or it will be red or blue or green, whatever may be the color, we can say that. So phenol when reacts with neutral ferric chloride, you get this particular compound, a complex compound, and you get a characteristic color, the color which I said you. So this reaction is used, listen carefully, this reaction is used to distinguish alcohols from phenol. Alcohol does not give this particular test. Alcohol does not give this particular test, but phenol gives this test. Alright. Now one more thing, note it. All compounds having enolic group, enolic means double bond C single bond OH, double bond C single bond OH. Here in case of phenol, you know that the carbon atom to which the OH group is attached, the carbon atom is double bond. Alternately single and double bond is there or not in the benzene ring. So carbon atom is double bond, so it is an enolic group. So all compounds having enolic group gives this particular test. So in case of aliphatic alcohol also, if you are having this particular double bond C single bond OH, alright, then this particular test will be given by aliphatic alcohol also. Understood now? Noted this particular thing. Again I repeat, all compounds having enolic group, enolic, in means double bond, olic means alcohol. So together it is called as enolic. So all compounds having enolic group, that is double bond C single bond OH, responds to this test. It gives this particular test. Fine. Now next is, you can see it on the screen, we are having some special type of reaction. Special type. We have done the electrophilic. Now we will come to the the miscellaneous reaction, the special types of reaction, that is a named reaction, but it is very very important, very important, this particular one. Okay, don't take that this is slightly special type means it is not going to come. This is only going to come in the exams. Alright, now see here. The first one is Cold-Smith reaction. You have to remember the name of the reaction also. So Cold-Smith reaction. So sodium phenoxide. Now how will you get sodium phenoxide? You know that. That is when phenol reacts with sodium hydroxide in presence of 573 to 623 Kelvin, 200 to 300 atm pressure, then you get sodium phenoxide. You know it. So when sodium phenoxide reacts with carbon dioxide, so I have written carbon dioxide in this way. Why? Because it undergoes an addition reactions. When I write a double bond, it is easy for you to understand that it undergoes an addition reaction. Now 400 Kelvin and 6 to 7 atm pressure. Alright, 400 Kelvin, 6 to 7 atm pressure, it gives nothing but you get, what is that? Benzene ring OCOONA. What is that? That is nothing but you get a compound, carbon compound, a carboxyl compound with sodium. You get it. A carboxyl compound, you get it with sodium. A carboxylic compound. A sodium salt of phenolic acid. That is nothing but phenyl sodium carbonate. Again I repeat, you may write it down, phenyl sodium carbonate, benzene ring OCOONA. That is phenyl sodium carbonate. It is a sodium salt of, what you can say, with phenol. We can say with carbon dioxide, we can say. So again I repeat, phenyl sodium carbonate. Now when it undergoes rearrangement, now it is a big compound, it will undergo rearrangement itself to form, you can see that, nothing but sodium salicylate, we get it. Clear? Sodium salicylate we get. Now which undergoes hydrolysis to give you nothing but salicylic acid or 2-hydroxybenzoic acid. The IUPAC name is 2-hydroxybenzoic acid. So you need to write this reaction and practice it. That is, you got benzene ring OH-COONA. Now I have to remove that Na. For that particular purpose, what I have done, I have used HOH/H+. You may use HCl also. HCl will give you what? Same product. Benzene ring, first position OH, second position COOH. By default that is the first, actually I am telling you. But actually benzene ring COH is the first position and OH is the second position. Okay, fine. So 2-hydroxybenzoic acid, for that reason you got it, or salicylic acid. And if you take HCl, then you will be getting NaCl as a secondary product. So this is your Cold-Smith reaction. So basically Cold-Smith reaction is used to prepare what? It is used to prepare salicylic acid. Now in the next you can see that salicylic acid is having several uses. Now salicylic acid, you see, it reacts with acetic anhydride, that is ethanoic anhydride in presence of glacial acetic acid. Now glacial acetic acid is what? It is a pure acetic acid. Pure acetic acid is known as glacial acetic acid, we can say that. So pure acetic acid. Now it is being used as a condition to prepare, what is that? Aspirin. Aspirin. What is the IUPAC name of aspirin? 2-acetoxybenzoic acid. 2-acetoxybenzoic acid. Which is acetoxy? OCOCH3. That is your acetoxy. 2-acetoxybenzoic acid. Benzene ring COH is your benzoic acid. In second position is OCOCH3. That is your acetoxy. So 2-acetoxybenzoic acid, you get it. Now, how do you get it there? Because glacial acetic acid, as I said, is a pure acetic acid. It pulls more of acetic acid molecules from the given compound. Why? Because it undergoes association of molecules. You have read it in lower classes. Even in class 12 also you studied in the solution chapter. It undergoes association of molecules, association by the help of intermolecular hydrogen bond. So hence it undergoes association of molecules. For that reason I have taken glacial acetic acid, because the pure acetic acid, it will, you can see it is pulling an acetic acid molecule from, that is phenol, from salicylic acid and acetic anhydride, and it forms acetic acid. Understood? As it forms acetic acid, the remaining product is your aspirin. Got it? Got the idea? Now next is, what you will do is that you take salicylic acid and reacts with phenol in presence of POCl3. That POCl3 here acts as a dehydrating agent. See here, a new dehydrating agent, you learnt it today. You have learnt Kong sulfuric acid, P2O5, anhydrous ZnCl2 and so many. But you haven't learnt about POCl3. So POCl3 is a dehydrating agent. It removes water. You can see water is being removed. And what I get it? I get it salol. That is phenyl salicylate. I get it? Salol, phenyl salicylate. Now salol is both an antipyretic as well as an analgesic. You know what is antipyretic? Antipyretic means which is used to bring down the body temperature Got it? It is used to bring down during fever. It is being used. And analgesic means it releases the body pain or headache or something like that. We can say that. So it also works as an internal and external antiseptic. Which one? Salal. It works as an internal as well as external antiseptic. We can say that. Salal. It's being used. Got it? Phenyl salicylate. Achha. Next one, salicylic acid when reacts with methyl alcohol or methanol in presence of HCl gas, reflux. Here also HCl gas acts as a what? Dehydrating agent. Refluxation I said you. Refluxation means when two substances in a liquid state do not react with one another, but when it is being heated in a reflux condenser, an apparatus is there, reflux condenser, it turns into the gaseous state. It turns into gaseous state. In gaseous state, they react with one another. So hence that process is called as refluxation. In liquid state, methyl alcohol and salicylic acid, they do not react with one another under ordinary conditions. So hence what I need to do, I need to put these two substances in a reflux condenser. When I put in a reflux condenser and I heat it, it turns into gaseous. And in gaseous state, they react with one another. As you can see there, the reaction. So this is called as refluxation. I told you earlier also. HCl gas acts as here dehydrating agent. You know HCl, you have studied in the lower classes that 452 volumes of HCl is soluble in 1 volume of water. That means 452 liters of HCl is soluble in 1 volume of 1 liter of water. So understand it. How much HCl is soluble in water. So it is going to pull the water molecules towards itself here. Say here HCl gas acts as a dehydrating agent. You can see it pulls the water molecule and hence you get methyl salicylate, which is the main constituent of oil of wintergreen. I have said the oil of wintergreen, if you remember it in methyl alcohol when I was teaching you. I told you it's the main constituent of the oil of wintergreen. Got it? And maybe pre-used for the esterification of what you can say process. Now this particular process we can see that. Clear? So basically what is being used, this methyl salicylate, it is being used for rheumatic pains. Got it? It's being used for rheumatic pains. You might have seen it that in your house, might be in your house, that is your either your grandfather or mother or anybody. If they are having some joint pain or some pain in their what you can say the ankle or the knees or somewhere, they are putting move. You might have seen it. So move contains that oil of wintergreen. That it contains oil of wintergreen, which is one of the constituents of methyl salicylate. We can say. Clear? And hence you can see it has got an odor, a particular odor. Alright, it may be pleasant to you or it may be unpleasant to you, that it depends, but it has got a particular odor. And due to this odor only, it is being also used in perfumes. Alright, this particular one. Clear? So that is the work of the methyl salicylate. Now next is your, this is all about your Cold-Smith reaction. Next we'll come to the Reimer-Tiemann reaction. Reimer-Tiemann reaction. So in case of Reimer-Tiemann reaction, you can see phenol when reacts with chloroform in presence of NaOH and 340 Kelvin. What do we get? I've given you the complete mechanism here. We got it, that is sodium phenoxide and second position CHCl2, because one chlorine goes with Na to form NaCl. You can see at the bottom. Clear? And that is HCl will react with NaOH to form NaCl and water is being released. We can say that. Now as 2Cl2 group is there, so hence we require 2 NaOH. Alright, suppose here would have been CCl3, I would have required 3 NaOH. Understood now? Here what you get it? The first product, benzene ring ONH CHCl2. Then over the arrow you can see I have written 2 NaOH. You know why it is 2 NaOH? Because 2 chlorine is there. Because it undergoes hydrolysis. Suppose there would have been CCl3, 3 chlorine. Then how much NaOH I require? 3 NaOH. Because it will be replaced by 3OH group. That is hydrolysis. Alright, so you can see it here. So what I am getting the product, there you can see it undergoes hydrolysis to give 2 OH group. Can you see it on the screen? And I said you that one carbon atom cannot have 2 OH group. Why? Because it suffers steric hindrance. Due to that reason, what happens? One water molecule is released. You can see minus water. I have shown you in the red pen. Water molecule is released. And what you get? You get nothing but sodium, that is nothing but salicylate, you get it. Clear? ONA, benzene ring ONA and CHO, which will further react with dilute HCl to give you nothing but, what is that? It will give you nothing but salicyldehyde. Alright, it will give you salicyldehyde. You got it. Clear? Plus NaCl. Now listen carefully. If I use carbon tetrachloride in presence of CCl4, then what I said I will be getting it? Benzene ring ONA and CCl3. And here how many OH group you will be getting it? 3 NaOH you will take, and how many OH group? 3 OH group. So 1 water will be released, and hence you will see that you will be getting ultimately salicylic acid. You write this reaction. You write this reaction and you show it to me. Got it? I have given you the reaction with chloroform. You please write down the reaction with carbon tetrachloride the way I have said you, and you show it to me. You send me in the group and you show it to me that yes, we have done the reactions. Always remember that one thing, children. You do it, then only you will be learning it. It is nothing but learning by doing. And one more thing, don't leave writing, otherwise you will forget writing. Alright, otherwise you will be forgetting the writing, because now you're basically your text, you are using that mobile phone or laptop or something like that, you're using it. So hence keep a practice of writing, otherwise you'll forget writing, and during the exams you'll not be able to write it down. You'll not be able to complete your answers in time. So remember my words. So hence keep on writing, keep on doing, then only you will be keeping on learning. So this is your Raimert-Thaman reaction as I said you. If any doubt is there, you can ask me. Thank you.